In the jungles of southern Mexico, an ancient Mayan city arises from the trees and vines. The city of Palenque has some of the best preserved temples, and one of the most impressive is the Temple of the Inscriptions, where a famous Mayan ruler is buried. The Temple of the Inscriptions has elaborate Mayan symbols, and like some of the Egyptian pyramids, includes a secret chamber where the king is buried. This jade mask was over the king's skull when explorers first found the secret chamber in 1952. At that point, the temple was over 500 years old. The Temple of the Inscriptions is an example of a rectangular pyramid. This is different from the pyramids in Egypt, which are square pyramids. The descriptions rectangular and square refer to the base of the pyramid. In the case of the Temple of the Inscriptions, the base of the pyramid is a rectangle. Suppose that the base of a rectangular pyramid has side lengths A and B. The volume of this type of pyramid is 1/3 ABH, where h is the height of the pyramid. But this formula applies to a pyramid that is complete. The Temple of the Inscriptions has a pyramid shape up until the level where the main temple appears. So the type of pyramid shape is more like this, which is a truncated pyramid. The volume of this pyramid is equal to the volume of the entire pyramid minus the volume of the pyramid-shaped piece at the top. For now, let's assume this is a square pyramid of base B. The height of the full pyramid is h1, and the height of the small pyramid is h2. The volume of the truncated pyramid is this. But the smaller pyramid is proportional to the larger one. Both heights are collinear. The sides of the smaller one overlap the larger one. Most important, the bases of the pyramids are on parallel planes. This results in the formula V equals h over 3 times the quantity B1 plus B2 plus the square roots of B1 times B2. But even this formula assumes that the truncated pyramid has a smooth surface. But that isn't the case with the Temple of the Inscriptions, or any Mayan pyramid. Instead, they are in a stair-step pattern. This can be modeled by a different type of three-dimensional figure. A rectangular prism has 6 rectangular faces and 8 edges. When all the edges of the rectangular prism are the same length, then the prism is a cube. In the case of the Temple of the Inscriptions, there is a stack of 8 rectangular prisms that decrease in size in a consistent manner. If we draw a rectangle over one of the rectangular faces of one of the levels and scale it down by 10%, we get a new rectangle that fits in the next layer. Suppose that the dimensions of the bottom rectangular prism at the base of the pyramid are A, B, and C. The volume of this rectangular prism is ABC. If each side length decreases by 10%, then the volume of the second tier isn't 90% of Tier 1, but 72.9% of Tier 1, as shown here. This is because the coefficient 0.9 is cubed. In the same way, the volume of Tier 3 is the volume of Tier 2, also multiplied by 0.9 cubed, and becomes Tier 1 times 0.9 to the 6th power. This table shows the relationship between the tier number and the exponent of the 0.9 term for the first 4 tiers. We can use the pattern found in the table to create a general term. This general term is part of a sequence of terms. To find the total volume of the pyramid, add the terms in the sequence, including the area of the bottom tier. The sum of the terms in a sequence is called a series. There is a simple way of writing a series that might have many terms. Use the summation symbol, sigma, as shown here. This is read as the sum from I equals 0 to 7 of ABC times 0.9 to the 3i power. And you can use the TI Inspire to find the value of the series. Turn on the TI Inspire. Create a new document. You may need to save a previous document. Create a calculator window.
Now, unless you are using an Inspire CAS calculator, your expression should only have numbers in it, so you will be inputting the following expression.
Press the Catalog button, which looks like an open book. Press 4 to bring up the tab that includes the summation symbols. Use the navigation arrows to isolate this summation symbol. Press Enter.
The cursor will be at the bottom left field. Input the letter I, and then press the right arrow key. Input the number 0, and press the right arrow key again. The cursor should now be at the middle part of the summation symbol, where the main expression goes. Input 0.9 to the 3i and press the up arrow. Input the number 7. Press Enter to see the result of the calculation. Rounded to the nearest hundredth, the result is 3.39. So the total volume of the truncated pyramid is 3.39 times the volume of the first tier.
In fact, look at the function y equals 0.9 to the 3x. The function is based on the sequence you just investigated. Look at the graph of this function. Continuing with the Inspire, create a graph window. Press Home and select the graphing window. Press Enter. At the function entry line, input the expression 0.9 to the 3x. Press Enter. Your graph should look like this. Recall that this graph represents the total amount of volume based on the number of tiers. So along the x-axis, the numbers represent the tiers, and along the y-axis, the numbers represent the volume at the given tier. So the total volume at any given tier is the sum of the y values up to that point. The Temple of the Inscriptions has 8 tiers. So if you look at x equals 8, you see that this tier makes a small contribution to the total volume. The Temple of the Inscriptions is built in such a way that the greatest amount of volume is concentrated in the smallest number of tiers. As you can see from the function graph, the graph extends to infinity. But as x increases in value, the tiers have a smaller and smaller volume. So the temple sitting atop the truncated pyramid represents the infinite, while the lower tiers represent the finite and terrestrial. This is important since Mayan temples had religious significance. While we don't know for sure if the Mayans had developed the mathematical concept of infinity, their mathematics certainly made it possible. For example, the Maya numerical system included the number 0, a remarkable achievement among the ancient cultures. Furthermore, the Maya's numerical system also included place value, in much the same way as we use it. With place value, it is easy to create very large numbers, and the notion of large numbers is the stepping stone to infinity. The one Mayan pyramid that best exemplifies the mathematical and the spiritual is the pyramid at Chichen Itza, which is several hundred miles from Palenque. Chichen Itza is a square pyramid that has 9 tiers, with a temple atop the truncated pyramid. The base of the pyramid is 55.3 meters on each side. The angle that the pyramid makes with the horizon is 53.3 degrees. As with the Temple of the Inscriptions, each tier is made up of a rectangular prism, and the side lengths from one tier to another decrease by 10%. The truncated pyramid is 24 meters high, but as you know, it is a cutoff version of a taller pyramid. What is the height of this virtual pyramid? Let's use the Inspire to find out. Create a geometry window. Press Home and select Geometry. Press Enter. You will be constructing a scale model of a side view of the pyramid. This will be a 10:1 scale drawing. Use the Segment tool to construct the base of the pyramid. Press Menu, and under Points and Lines, select Segment. Move the pointer to the middle left part of the screen. Press Enter to define the first endpoint of the segment. Press the right arrow to move the pointer in that direction. You'll see the segment take shape. Press Enter. Measure the segment. Press Menu, and under Measurement, select Length. Move the pointer above the segment you just created. Press Enter to record the measurement. Move the pointer below the segment and press Enter again to place the measurement on screen. Press Escape and move the pointer above the measurement. Press Enter twice to make the measurement editable. Press the Clear button and replace the value with 5.5, which represents 1/10 the length of the base of the pyramid at Chichen Itza. Now find the midpoint of this segment. Press Menu, and under Construction, select Midpoint. Move the pointer above the segment and press Enter. You will now see the midpoint, where you will construct a line perpendicular to the base. Press Menu, and under Construction, select Perpendicular. Since the pointer is right above the midpoint, press Enter twice. You should now see a line perpendicular to the base at the midpoint. Press Escape and move the pointer to the end of the line. Press and hold the click key until the pointer changes to a grasping hand. Use the up arrow to extend the line. Extend it to the top of the screen. Now construct an angle that includes the base of the pyramid. Press Menu, and under Points and Lines, select Segment. Move the pointer to the right-hand endpoint of the base of the pyramid. Make sure the pointer is right above that point. Press Enter. Move the pointer up and to the left, about halfway up the screen. Make sure that the segment intersects the perpendicular line you previously created. Measure the angle. Press Menu, and under Measurement, select Angle. You need to identify 3 points to measure an angle. So move the pointer to the midpoint of the base segment. Press Enter. Next, move the pointer to the right-hand vertex of the pyramid base. Press Enter again. Finally, move the pointer to where the perpendicular line and the segment you just created intersect, and press Enter one more time. You should now see an angle measurement appear. Press Escape and move the pointer to the farthest endpoint of the slanted segment. Press and hold the click key to select the point. Move the point up or down to change the angle measure to 53.3 degrees. You may need to move the endpoint further up and to the left to get the angle right. If you can't change the angle measure to 53.3 degrees, make it as close to this value as possible. Now, measure the length of the segment from the midpoint at the base to the intersection point of the perpendicular line and the slanted segment. This is the height of the complete pyramid. Press Menu, and under Measurement, select Length. Move the pointer to the midpoint and press Enter. Move the pointer up to the second endpoint and press Enter again. You should now see a measurement appear. Move the pointer to the left of the segment and press Enter one more time to record the measurement on screen. The height of the pyramid should be 3.7 to 3.71. Since this is a 10:1 scale drawing, the actual height of the virtual pyramid is 37 meters. Since the height of the truncated pyramid is 24 meters, then there is 13 meters of virtual pyramid. But as you have seen from the graph of the function, most of the volume is included in the 9 tiers that are there. What percentage of the volume is enclosed in the 9 tiers? For that, you need calculus to find the area of the curve. But you can use the Inspire to calculate a close approximation. Create a new calculator window. You want to find the ratio of the volume of the first 9 tiers over the volume of the entire pyramid. Use the expression you used earlier with the Temple of the Inscriptions, 0.9 to the 3x. Create a fraction to calculate the ratio. Press the Library button, which looks like an open book. Press 4 to bring up the tab that includes the fraction template. Move the pointer to the upper left-hand entry and press Enter. In the numerator, input a summation sigma. Press the Library button again. Since you were previously in tab 4, then move the cursor to the sigma template that includes the upper and lower limits. Press Enter.
Input I in the first field and press the right arrow. Input 0 and press the up arrow. Input the expression 0.9 to the 3i. Press the up arrow and input 8 in the top field. You want to copy this entire expression to paste into the denominator. Press the left arrow so that it is to the left of the summation expression in the numerator. Press the Shift key followed by the right arrow. This should highlight the entire numerator. Press Ctrl and C to copy the expression. Press the down arrow to go to the denominator. Press Ctrl and V to paste the expression. You want to change the upper value from 8 to a much higher value. Ideally, the value should be infinity. A good approximation will result even with a value of 100 or 1000. Input the higher value and press Enter.
The temple at Chichen Itza was also a kind of calendar. There are 91 steps on each of the 4 sides of the pyramid. These add up to 364. The temple at the top is the 365th step, so each day can be marked and identified on the pyramid. The orientation of the pyramid is such that on the fall and spring equinox, at a specified time of the afternoon, the shadows along the stairs form 7 isosceles triangles that are aligned along the diagonal. They meet at the bottom of the stairs, where the head of a serpent can be seen. Together, the light-formed triangles and the snake's head are meant to evoke the Mayan god Kukulkan. The feathered serpent comes down from the heavens, from the infinite expanse of space, and approaches the ground where man lives. This is astonishingly similar to the behavior of our exponential function for the volume of the pyramid. Its graph descends as x approaches infinity. Now, the Maya were not aware of calculus, the area under a curve, the graphs of exponential functions, or infinite series, and yet their architecture shows an awareness of something beyond what can be counted. Through these mystical pyramids, the Maya took steps toward the infinite, beyond the day-to-day. The geometry of the pyramid gives us insight into their view of the world and the universe.